Hello, good afternoon, everybody. Welcome to the second part of our business intelligence module. This is your lecturer, Dr. Mustafa Muhammad. Thank you for following up with my colleague Philip for the first part, where you've been introduced to what is business intelligence and different systems and how this is a sort of information system, how big data works. You've been through SAS and you had a good introduction of SAS. I guess you developed sort of advanced analytical skills in using SAS. So in the second part, I will get you into a deeper level of understanding towards business intelligence. This week we will start with data modeling, and in practice we will talk about Python, how we can write variables and functions. And later on I'm going to talk to you about data mining and further step. So both sections will complement each other's. Just to let you know that I will have separate videos for the assessment to help you further, and we will have 2 weeks according to the teaching and learning plan. We will discuss things together. We will give you one-to-one feedback, though it's not written feedback, but if you send an earlier draft, me and Philip will try to read and then they give you a sort of how to improve advice. Okay. In lecture 7, I'm gonna take you through 3 elements. The first one is talking to you about a practical example of pollution index. And in this example, I will show you the difference between descriptive, diagnostic, prescriptive, and predictive analytics, and why we need data modeling when it comes to predictive and prescriptive analytics. And then I will take it from there, from that example, to tell you how data modeling works as modeling house, who is involved, and how we can define data modeling. The second part, I will talk to you about the level of data modeling, 3 levels, frankly, with examples. And the third section of this lecture, I'm going to talk to you about types of data modeling, entity relationship diagram, object-oriented, and different interesting ways of modeling data. I will take some examples from tables and I will show you the logic behind these things. And then you can take it further in your own way and apply it to what you learn here to SAS or Python, whatever you are interested in. Just to reaffirm that I'm not trying to integrate between what you learn from Python and SAS. You could just reflect on one of them. Okay, you don't need both actually. Though the new fashion and the challenging thing is to try to mix between both, which is still okay for me, but you don't have to. Okay, so I will take you through the first section, where first talking about the objectives, how we can have deeper understanding of prescriptive analytics based on an example, and we will define data modeling. Later on in the same section, we will try to understand together the process of creating a data model for business intelligence system as a sort of information system. What are the key data modeling techniques and their progression across time, across history. We will try to understand together the process of defining and analyzing data requirements with stakeholders, including users, and how we can engage them in the process. So we will try to cover these things together. In the first part, I will take you through a pollution index example. So let's assume that you are collecting data about the pollution index in the top 5 economies in UK, not in UK, I mean in Europe, sorry. So let's start with 5 countries, and you will collect the pollution index from World Health Organization, from the World Bank, and let's assume that you are trying to collect data about 2019 and 2020. Let's assume that you have this table So you will have your Excel spreadsheet. You have the first column for the countries, top 5 in terms of the pollution index. And what you be interested in is to start with this descriptive analytics. So you will go for insert, and you will try to use maybe bar chart or pie charts or any visualization techniques. And what you can easily do to describe the situation is to highlight what happened. So frankly, you describe in UK, this was this number in 2020, and then in 2019 it seems there are different numbers, and it frankly tells you what happened, but doesn't tell you why it happens this way. So if you wanted, for example, to analyze and diagnose what was going on, you might calculate the increment or the change, the difference. And the difference would tell you later on if there was any enhancement in the pollution management strategy, if they have carbon emission or footprint strategy. And in this case, you will see a sort of decrement in or decrease in the pollution index. So this is a descriptive analytics, and the second layer is trying to use difference or variance analysis. And in doing so, as you can see here, the green area, the light green area in the tail of each bar, that tells you about the difference. But then you can always go deeply and see if this difference seems all of them have a positive difference. And you can always find out again from the previous diagram. It seems that a country like UK it didn't manage to decrease the carbon emission as France, as Netherlands and Germany. It seems from these numbers and the analytics here that they have a better carbon emission management and pollution management plan. So this is a diagnostic analytics. The third level, where you can try to do predictive analytics and try to see the future. So in this table, as you can see, we might have expectations. So let's assume you are back in 2018, and you set some expectations for 2019 and then 2020. And based on this, you can even calculate the expected increment. So you start in 2018 having these calculations, expected pollution index in 2019, and again expected pollution index in 2020. And you can earlier on have the expected increment or the expected variance in the last column, as you can see. Later on, when it comes to the end of 2019 and the 2020, you will get the actual numbers. So the next layer, not predictive, will be prescriptive, where you can see the differences between the actual and expected, and then you try to see all these layers of descriptive, diagnostic, and predictive all together to do the prescriptive and take correction plan. So what can UK do to improve? But clearly UK was expecting almost 16% or 16 increment in the sort of index, in the pollution index, while in actual terms they got 2.35, which means it seems they did pretty well in comparison to what they expected. So again, we use bar charts, and you can say this is expected increment in pollution index between 2019 and 2020, and you can see the expectation, and the light green area is big, which is predictive, but then this is the prescriptive level, where you can have, as you can see, the first column for UK is expected 2019, while the actual 2019 is next to it, and you can see the difference here. So it seems that the actual performance is better than the expected performance, which tells us there is a hope. But what can we do? What can we learn from Italy and Germany and other things? This is again part of the prescriptive analytics. To do so, you need to have a sort of model, data model. How would you do the expectations? Do you have a common factor? Do you have a multiplication or a multiplier? Do you have division? Do you have data mining? Do you have a data model to compare and contrast? Are you comparing and contrasting between expected and actual? Are you using averages in between? There are more complicated calculations as you go that would require SAS and Python and R and other advanced things. So, as you can see here, the pollution index variance for these 4 countries is pretty clear, so we can compare between them to do the prescriptive analytics. So to do so, we need data modeling. And again, if you go back to my first lecture, when I explained the descriptive and predictive and prescriptive, it seems to move from descriptive to predictive and prescriptive. We would require, as I told you, to get what will happen and why will it happen, what should I do and why should I do it this way, optimize. So we need a sort of more modeling, decision modeling, expert systems, the best possible business decision and the transaction to be done in the future, which would definitely require data modeling. So what is data modeling? I mean, I want you to think with me this way. You invested on buying building material. You build 5 floors. This is the top floor. You have stairs everywhere, and suddenly you see people cannot really use the stairs because you have the barriers just very close to the stair, and it stops everybody from using the stair. The top stair doesn't really lead to a flat or a room, just leads to a window that you can jump from. This would happen if you don't have a data model. So similar, if you bring a group of constructors, they do amazing job. You have carpenters, plumbers, all of these people would work together, but no communication, no coordinated plan. This will lead to a house that could be look like upside down. So the door has no ground, and you will see things just upside down. So they are done, but they are not well organized, structured. So this is what we mean by data model, and this is why we need data model. So let's assume you are trying to build a data model. You have something called the modeling house, or per se, a group of people will do it. So the owner of a business would look at the stakeholders and then tell you his strategy and his objective. And then he need to work with data modeler. So this is you, me, our team. We will try to develop a blueprint architect, and then we will ask somebody, a developer or a programmer, to develop this data set. So he will have a database administration and arrangements. He's a developer. He will start building the data warehouse. The owner from time to time need to engage with different stakeholders, including users. Again, tell the architect, and the architect somehow is an intermediary. He's somebody who has good experience of the technical side from the engineering, from the engineer, and the business side. He is a stimulator of business intelligence here. Each one of these guys would include and build a different level of data modeling, as we will discuss in the second section. So what is a data model? What is data modeling? Is it just one activity or a sort of process? It is a process of creating data model for information system and business intelligence is an information system. By applying data modeling techniques, it's a way to define, analyze data requirements by the business owners and then stakeholders to support the business processes and do things in more precise manner. The process of data modeling involves these professionals that I spoken about, the data modelers themselves, the technical engineers and stakeholders and the owner and other people. So if we tried to define this concept of data model is a conceptual meaning of a set of tools to describe data, the relationship between these data. So, for example, there is a list of material that are required for building number 1 and number 2. Who is in charge? There is an engineer. So you have a list of engineers, and there is a sort of entity and attribute. There is a column, a specific column, which gives you the staff code for the engineer. And once you enter this staff code in the dataset, it tells you how many buildings he is responsible for, what sort of material and budget he can sign off, similar to these things. So it's a conceptual representation of data structure required to build a database. It's a very powerful tool in expressing and communicating business requirements. So, as I told you in our first lecture, information is everything. You is information, me is information, marketing is information, strategy is information. Informatics-wise, once you have access to this data model, you have access to business processes, because every process is a sort of information expressed. You can turn this data model into a visual representation later on, and based on this visualization, you can present it to other business people, you can attract funding, and you can navigate further, you can engage different stakeholders by expressing this data as evidence. A data model would have different levels, mainly conceptual level, logical, and then physical level. So, data modeling levels. This is the second part of our lecture, when we are going to talk about these 3 levels that I just mentioned with more examples. But before we go ahead, I want you to think this way. Why we need data modeling? Why it's significant? Why it is such a big issue? Start talking about visual representation of data. It's quite necessary because it helps improve data analysis and it makes it quite easy to communicate the results and then the contents of your data. It provides a holistic picture of the data, which can be used by developers to create physical data set later on. So remember, you start with the data modeling at the conceptual level, where there is a business owner and a business consultant, his consultant, and they try to understand the business environment, the threats, the challenges, the opportunities, and they give you what they really need, a strategy. But then after this, you need to communicate this with other people at lower level of data modeling, and we are gonna go through these 3 levels in a few seconds soon. All important data of an enterprise, and you studied the enterprise systems with Philip last weeks. All these important data of an enterprise are accurately presented in the model, otherwise it wouldn't be a model. This is why it is important. It reduces the chances of miscommunication. It reduces the chances of data omission by luck, and you always have a model, a system to organize data. Data omission can lead, if you tried this before, and can lead to incorrect results and faulty reports and miscommunication between different stakeholders. The data model portrays a better understanding of business requirements. Because it simply try to quantify things in terms of information and they try to make it clear and sharp for everybody. The data model helps the creation of robust design that brings the entire data of an organization or a network of organizations on the same platform. So they might have cloud or universal access to it, and it assists in identifying the redundant, duplicate, inconsistent, missing data. A qualified data model helps in providing better consistency across all projects of an enterprise. It improves the data overall quality as well. And it somehow helps project managers with a better scope and the quality management by performing the overall performance to the core and benchmark with other institutions. It defines a relational data, how tables and how records are related together, the way we should store such data, so the stored procedures and primary and foreign keys and codes and IDs for tables and records, how they relate to each other. The next step, after we understand what is data modeling and why it is pretty important, is to go through these three levels of data modeling. So there are pretty three levels. The conceptual level, which is done by the business stakeholders through the business owner and his consultants. So there's a wide audience out there. They communicate, define business terms, rules. They set a key objective to overcome a key problem, and this is pretty much the same that you do in your group presentation and in your individual assignment. And then the logical level, it's more data architect or data analysis stuff. So it gets done by a business analyst and the data architect. So a consultant and a technical guy who is mainly an engineer, they will have more clarification in terms of the data structure, types of table, each table, what are the key contents, how tables are related together and connected together, what type of information or data will move from this to that. This is more what could be done to specify things. So I would say the conceptual level is what is all about and what is needed. How it could be done in terms of more details is the logical one. And when it comes to how to manage it, we are talking about setting a practical database in Access, R, Python, SAS, any of these business analytics and business intelligence systems. So the database admin is a developer himself, and he will have a technical implementation of the physical data set, the way he manages records in a daily basis. So the conceptual data model is more done by the business owner and then his system analyst. The logical data model is more about the data architect and how it could be done in general, the structure. In more details, the physical data model, which works in a daily base in details. So the conceptual model, again, it describes pretty what the system contains, what sort of key features and boundaries of the system needed to achieve the corporate strategy. It defines what we need to do in terms of the structure of the model, how it could be organized, who have authorized access to what type of data, what sort of stakeholders and their authority and their objectives, and how any conflict would be sorted out at sort of external to internal environment. It mainly focuses on business-oriented entries, the attributes and the relationships, how the structure and the boundaries, as I told you, And the word attributes would be explained soon. Frankly speaking, is a sort of unique ID for each table. It's a column that includes non-repeated data, and each cell in this column has a sort of special feature. This is the attribute. Relationships would be how I relate between data. So let's assume student and teachers. A teacher would have a table talking about his timetabling and what sort of modules, and within each module there are subtables that tells how many students and who they are. So the relationship between teacher table and the student table would be one to many. He would have access to many students' tables, while each student will relate to one tutor or one teacher. So a relationship, which we will explain more in details, could be one-to-one. So one piece of attributes or information would move from one table to another, or maybe one to many or many to many. So it depends. It basically designs or a sort of byproduct of the data architect work and the collaboration with business stakeholders. So if you remember this house that we spoken about and how the stairs been organized the wrong way, if there is a sort of paired review or overall review of how the stakeholders can engage together by the business owner or the owner of this building, it would go the right way. But if you don't have this conceptual model, the data model that you have would look like this house. It's completely out of place. The level of data modeling, again, the middle level, is the logical model that tells you how the model should be implemented, how the data architect as engineer can implement it, which platform, which data mining platform would be used, and we're going to talk about data mining later on. Includes all kinds of data that need to be captured using tables, columns, how data could be organized, how data could be retrieved. This model is generally designed by a business analyst and data architect, as I told you. Then when it comes to the lower, deeper level, which is managed by the database admin, is called the physical model, which defines how to implement a model, a data model, with the help of database management system, or the technical platform and data mining platforms that we will talk about next week. It outlines the implementation and methodology in terms of what sort of operations, indexes, partitioning, coordinality, or how the relationship could be developed in more details, deletion of data, cleaning of data, all these things. So this is a sort of lower level layer of the data model. The third section of today's lecture is going to be key types of data models. So I'm going to talk to you in more details about these key types of data models. I will start, let's assume that there is a customer, you are a customer, and you are trying to buy something online from Amazon. And Amazon is having a sale, like Black Friday sale. So what are the key actors here? The key actors here would be, frankly, I would say nouns. So humans and things, these are nouns. So customer is an entity. We call it an entity because he's an actor, he can do something. Product is output, which is a thing. This is an entity as well. And the sale is an entity, is another entity. Now we will see how the relationship between these entities. We will require for each entity, we will need a table. And each table for this entity will have a key column, we call it attribute, or a column a table key. So the table key is the attribute. And then what type of data would move from entity to another, from a table to another, and how many are they? This is the relationship cardinality. What type of relationship? So the relationship is the data that moves between tables. The cardinality, it could be one-to-one, one-to-many, many-to-one, many-to-many. This is the cardinality of relationship. So the piece of information that we can get, for example, you have for customers, you have a table called customers table. And in this customers table, the key columns could be customer number, a special code for the customer, or his name, first and last name. So these could be key attributes. For product, the product code could be an attribute. The relationship, for example, tells you if you wanted to find out a product price that is pretty expensive and you want to give a discount for customer, so you can get the product number from the entity of product table, and you will find this in the customer table. So you go to the customer table, you find the last orders, and you can find the code of the product that leads you to the product table, and then in the product table you can find the latest price for this item. So this is a sort of relationship. This is what we mean by a relationship. So if you look at this table, for example, this is what I referred to. You have a customer table, which is entity. The attribute would be the customer number, as you can see, or the customer name, or it depends, it could be the online access, the IP address, if it is mainly online. Sale itself is an entity because this is an event. And we in any sale we would have the customer number who bought this, the product code of the product that been bought, maybe the date, so we can chase them. But frankly, in this case, customer number could be the attribute, and the attribute between different tables could be similar, but within the same table the attribute shouldn't be repeated between rows. So it's a unique feature. Every row has a different value. The product is another entity, and the product code it could be the attribute. Now let's see how the relation. We have one for the product and one for the sale. So let's assume that you have a data model and the data set, the physical data set, and you are looking for a price of a sale. So in a specific event, there was a discounted price offered for a customer for a specific product. So what you need to do is find it using a product code on the instance or the date of sale that you are interested in, and look up the corresponding price on the product entity table with the matching product code. The attributes of customer would be a customer number, because this is a key column where you can find unique features for customers. The first column, customer code or customer number. And if a customer wants to investigate something about a price he paid for the product in a specific sale, so we would start by customer number, which leads us not just from the customer entity, but it will take us to the sale entity and the product entity, and all of them are related. The sale itself has a composite of primary key, which is product key or product code as well, is one of the key attributes. But any sale would have information about, could actually have more than one attribute. So the attribute is a unique feature column, which could have the attribute of customer number, customer name, or product code, or maybe we can create a column for a sale code. So in this event will be a specific code for the sale. But frankly speaking, is the relationship between the customer table and sale table is one-to-many, because each customer would have one record of many sale events where he or she could get different discounts for the same product. Okay, and the relationship between sale and product is actually many to one, because the sale table would have many events where the same product have been sold with different prices and in different places to different customers. So this is called the cardinality. So the cardinality is this line that starts from one to many between customer and sale tables, and many to one, which starts between sale and as a table and product as a table. So let's go. There are 6 types of data modeling or data models that we are going to discuss as maybe the last section of today's lecture, as though we are going to address the advantages and disadvantages later on. So 6 types. The first one is hierarchy, and the meaning is quite clear from the word. So you have a parent record and you have a children record, and it specifies one to many relationships. So one table feeds many other tables, or maybe a few tables from different departments feed one table in the whole executive level or top level. A relational model, which we are going to discuss in a few seconds, networked model or network model, which is a sort of advanced hierarchy model, object-oriented database model, entity relationship model, and object relational model. So let's go ahead. Let's start with the hierarchy one, which is based on a sort of tree-like structure. Each of the records has a single root or a parent. So if you start from the bottom up, every table relates to a parent table. So there is an attribute in this table that goes to a parent table. And the parent table is frankly a mix of attributes. That's it. Just attributes that relate to different children. So the order is used as a physical order for storing data. This level of hierarchy would go to a smaller size and the traditional business. You can use this type of modeling for real-world modeling relationship. Actually started a long time ago in the 60s, almost decades. 6 decades history of this type of modeling. Though it is a bit inefficient when it comes to more complex data models and organizations where you have multi-stakeholders and you have many branches. So this is how it looks like. This is just an example. So you have the warehouse and you have a manager of the warehouse accessing the warehouse, a sales rep, and the customer. The store record would have attributes from each of these tables, and the 3 tables would feed back into an order and other things. So you can see the hierarchy. Mainly this relationship between store, salesman, manager, and customers as entities. The second type is networked, which helps in more complex hierarchy. So it is hierarchy model, but more advanced, which allows multiple relationship among the parent record and many children. It definitely would require mathematical modeling to set this. It consists a set of parent records, so not just one parent record. So let's assume that we have multinational corporation, you have a headquarter, and the headquarter will have many parent records, a parent record for logistics and supply chain, a parent record for marketing and sales, parent record for accountancy and finance, a parent record for HR, and each branch will have parent records as well that feed in the higher level parent records, and then there are children records within each branch. So each record can belong to multiple sets and allow the model to convey complex relationship, and this is how it looks like. So you can see, for example, me receiving a message from a client through a mobile app, and this feeds back into maybe delivering sort of music or digital service. There are many attributes that relate between this parent and the children. There are many parent and many children tables with different attributes, so it's complicated, frankly. The third type is the relational model, which frankly it relates the relevant things to make a piece of information. It reduces complexity, so it doesn't address complexity, it actually makes things more simple and reverses the complexity. It doesn't require a specific data bus, though it just relates key attributes from different tables that would make sense together. It is more judgmental, and then the key language to develop such a data model is SQL, or structured query language. So let's assume that we have three tables. One table for warehousing and the warehouse management. This is the top one. The right table addresses the timetabling of the warehousing stuff. The bottom one talks about logistics and routes for each product that gets into the warehouse. And you can see, for example, for the timetabling to be done, you need the activity code and you need the activity route. So it makes sense if you want to develop a better supply chain, more efficient supply chain for your inbound logistics. Another type, which is object relational model, and this is a bit different because it doesn't follow key attributes as per se, like customer number or code. It relates things to objects, and each object would have key information or key characteristics and a method on how this could be done. So an object in this case would be an action, a process that has been done. So we can think of a relational model with advanced functionalities, and put these functions and processes in objects, and in each object we can clarify the steps to be followed in each object. I will show you an example here. So let's assume that you are picking your child from a school, and you want to have one fun day for your child. So we're going to say child is an object, and we will create a table for your child. The attributes would be name, age, gender, hair color, and other things. The method of entertaining your object would be pick up toys, eat dinner, play, and other things. So characteristics that describe the child would be the attributes, how we can describe him as object and differentiate this object from other objects. The tasks that the child object can perform for entertainment would be the methods. So you can see these things come from different other tables. The case here is not relation, but the object, whatever the object requires to be identified and perform the preset activities. The last model, not the last, the one before the last model that we are going to address here, object-oriented dataset or database model, which is sort of hybrid. It consists a collection of objects, okay, and these objects have associated features, states, and behaviors, as you could see in the object relational one. Each object is identified using a unique object identifier. So again, it has a mix between the identifier characteristics of the hierarchy model and the object-oriented or relational model. So the object-oriented is a mix of hierarchy and the relational model as well. For example, a student has status such as name, date of birth, and addresses, and attending classes, writing exams. These are activities that we can associate with this object. So this is just an example of what I just mentioned before. Another type is called entity relationship model, and in this entity relationship you have tables with ID. We call it primary key in this case, and in every table you have attributes that are not primary key. So in this case we differentiate between a top attribute, we call it primary key, and we highlight other alternative attributes later on. And when it comes to special relationships, primary key will be different. So if we talk about university student and teacher, the primary key could be the student ID. And the rest, name, age would be just objects, other attributes, sorry. But if we wanted to create a sort of entity relationship between a university student and healthcare, in this case we might need student age to be a primary key, or it could be the national insurance number associated with his records. So we can have another attribute. So still the same table, but the primary key would be different based on the relationship. So far, after we discussed these key data models, the advantages of data modeling, especially for business intelligence, data objects provided by functional teams and different stakeholders will, make things stable. The processes could be standardized. We will follow the data set, which is based on the data model. It allows you to query data, retrieve data, drive various reports and publish this. Somehow it contributes to data analytics and advanced data analytics, especially when it comes to prescriptive and futuristic insights. It improves the quality, as I mentioned before. It provides structured system. Same thing what I mentioned about the significance of data modeling. But when it comes to the dark side and the disadvantages, somehow you have to follow this data model that you fixed. If you don't have a backup, and then if the data model doesn't work, you lose a lot, and you might change, have a break in your business. So development of data model is very tedious job, especially when it comes to a network. We should be aware of the physical characteristics of the data storage. If it is not cloud-based, for example, it's not that agile or flexible. So you have a server, you set a data model, and then if it doesn't work, it doesn't work. People with different languages, with different software and hardware characteristics might not fit with the same data modeling. So especially the physical side might not be easily coordinated. It would involve complex applications development and knowledge of biographical truths, and once it gets breached, hacking would be quite easy, and our institution would be vulnerable. So if you have a data model, the structure and the sequence of data and organization information would be quite easily traceable. So this is part of the disadvantages of developing a data model. So far, we covered many elements today. In this lecture, we covered differences between descriptive, diagnostic, prescriptive and predictive, and these things have been applied in pollution index example with diagrams and visualization, and definitely you can do more advanced things and visualization with SAS. We've been through definitions of data model and why it is really important. We've been through different levels. We've spoken about the conceptual one, the logical one, and the physical, detailed one. Who is involved? How this could be done? We've spoken about the main objectives of data modeling and how useful it is, and the bad side of it. So I will let you enjoy today's lecture. Please cover the reading. It's just 2 simple chapters in one of our core books. There is a link to get access to the book, so feel free to go and try to download it. It is a web resource, so you can do this, or if you prefer to have a hard copy, please go and visit the library, and definitely there are copies available for this book. Have a good day today, and please stay in touch, and see you all in our seminar number 7.